Planet 9 might not be a planet at all, but something else entirely. Planet 9 is proving difficult to pin down. The mysterious hypothetical planet, somewhere beyond the orbit of Pluto, has so far evaded all our efforts to find it. We get it, it's very dark, very cold, and very far away, none of which is conducive to detection, and we have only a vague notion about where it might be. There's a lot of sky out there and only one dark mote. There are several possible reasons for this. We just have not seen it yet is one. Another is the very real possibility that it's just not there, or it might not be a single planet at all, but a swarm of rocks, or according to new research conducted by physicist Catherine Brown of Hamilton College and Harsh Mathur of Case Western Reserve University, what we have interpreted as evidence of a planet could instead be a sign that something is missing from our current model of gravity as described under general relativity theory. According to their recent study, the subtle abnormalities in the orbits of various objects, some attribute to the hidden planet, are also consistent with a different kind of gravitational model, one called modified Newtonian dynamics, MOND for short. Newton's laws are useful things, there's no doubt, but they are not exactly perfect. The laws in Newton's law of universal gravitation were resolved by Einstein's theory of general relativity. MOND is an alternative solution that proposes other gravitational effects take over when Newtonian gravitational acceleration drops below a certain threshold. Because MOND can describe the gravitational behavior of galaxies that does not seem to be tied to normal matter, unexpected rotation curves and lensing effects, it's an attractive alternative to dark matter, but it has not really been studied on smaller scales. MOND is really good at explaining galactic scale observations, Mathur says. I had not expected that it would have noticeable effects on the outer solar system. The existence of Planet 9 has been inferred based on some strange orbital clustering observed in our outer solar system. There, enormous numbers of small icy rocks can be found on large circumsolar paths. The way some of these rocks have been observed clumping together in their orbits suggests they have been herded by the gravitational influence of a large planet. Brown and Mathur thought that these clustering observations might not be compatible with MOND. They undertook an investigation modeling the orbits of the outer solar system Kuiper belt objects under MOND to observe how they behave. Surprisingly, what they ended up with was a bunch of rocks behaving pretty much exactly like the observed clustering. Their calculations suggest under MOND theory, some of the objects in the outer solar system should be dragged into alignment with the gravitational field of the Milky Way galaxy over time. That's not enough to confidently assert that MOND is responsible for the strange behavior of these distant rocks rather than a planet. We just don't have enough data either way. It does throw MOND into the mix of things that could be out there instead of Planet 9, though. Dynamical simulations would allow for a more detailed probe of the MOND hypothesis and help cement it or rule it out. Regardless of the outcome, Brown says, this work highlights the potential for the outer solar system to serve as a laboratory for testing gravity and studying fundamental problems of physics. And the research was published in the Astronomical Journal, and this is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.